Consider this situation, all of you. Okay, let's say there's one block suspended on this side. And another block is connected to the other pulley. Let's say this block's mass is 4 kg. Right. Assume pulleys and strings are ideal. What do we mean by ideal strings? They are massless, they are inextensible. And an ideal pulley is also massless and it is frictionless, means the string can simply or very smoothly slide over it. Okay. Right. So you all from your like based on your logic, you tell me if we release this system from rest, what will happen to it? Use your imagination and tell me, don't do any solving. What do you think happens to this system if it is released from rest? Rishi, what do you say?
Or if we like,
Hmm.
Sir, by release from rest, do you mean like pull the string? Like,
No, we won't pull anything. Let's say the 2 kg and 4 kg were held there. Now we just leave them. What will happen?
oh, then the 2 kg will go slightly up because of the mass of the 4 kg.
Okay, 4
Because
kg
there
is
are,
heavier, so you're saying
yeah,
2 kg will go up. Okay. What if it was like this? Just a moment. Suppose the 4 kg is here and the 2 kg is connected here. What do you say would have happened?
uh, uh, two-
Okay, Yusuf, what about you? What do you think?
So the 4 kgs goes down.
Why?
So it has more weight.
Because it is heavier, you're saying it will go down. Okay. Aishwarya, what do you say?
Sir, I think as the 4 kg block comes down, the 2 kg block goes up.
Okay, so you're saying 4 kg will come down and 2 kg will go up. Let's see.
So I have a doubt, sir.
Tell me.
So is the 2 kg pulley over there, is it fixed or is it just there?
See, it is supported on that string itself. That pulley can move. It's not fixed.
Okay, sir.
Okay. So yeah, all of you think that 4 kg is going to go down, 2 kg will go up because 4 kg is a heavier block. Fine. Let us check if this system can be in equilibrium. Okay. How do you do this? How can you tell, like all of you said that 4 kg is going to go down, 2 kg is going to go up. So you decided that it won't be in equilibrium just because 4 kg is heavier. Based on that you told. But let's do some calculations and check if the system can be in equilibrium. Tell me what forces act on the 2 kg block, and for it to be in equilibrium, how much should the forces be? What forces
Sir,
act on the 2 kg block?
on the 2 kg block, there'll be 20 Newton.
20 Newton weight
the
will
way.
be acting. Yes.
Yes, sir. And then the tension T will be there for the string.
Okay. Rishi, in this situation, how many strings do you see?
Sir, 1 and 2. 2.
2 strings. Okay, one long string and one short one connected to the 2 kg. Now you said there will be tension acting on 2 kg. Which
Yes,
string?
sir.
Which string exerts tension on 2 kg? Others also listen to
The,
this carefully.
the one it's connected to, sir.
Yeah, the one that is connected to it should exert a tension on it. Fine. So there will be a tension acting on 2 kg this way. Fine. For 2 kg to be in equilibrium, now we just want to check whether this system can be in equilibrium or not. For 2 kg to be in equilibrium, how much should the tension in that string be? How much should the
20
tension?
Newtons, sir.
20 newtons, correct. Obviously, it has to balance its weight. Okay. But we don't know if this happens or not. We are just checking if it is possible. Okay. What forces act on the 4 kg block?
So 20 Newton, no, so 40 Newton downward and the tension of the this thing 40 Newton upwards.
Its weight 40 newtons will be acting downward. And there is a string connected to it. Is it the same string which is connected to the 2 kg or a different string?
Different strings, sir.
Different string, clearly. So we should name the tensions differently. You can't call it T and T. Tension in one string, if you call it T1, then in the other string, you're supposed to call it T2 or whatever. Just give it a different name. Okay. Now for 4 kg to be in equilibrium, how much should T2 be?
So 40 Newton.
40 Newton. We don't know if it is that much or not, but for equilibrium, that much is needed. We'll see. Now, the cases that we discussed yesterday, there was only one string. So it should maintain the same tension everywhere. We could tell whether, like, we decided whether equilibrium can be established or not. But here there are 2 strings. How to tell whether these tensions are possible or not? Like yesterday, I'll show you one question. This case itself. We first discussed if tension can be 20 or 30. Okay, if tension is 30, 3 kg will be in equilibrium, but 2 kg won't be, which doesn't make sense. Tension is 20, 2 kg will be in equilibrium, 3 kg won't be. That also doesn't make sense. Okay, so that way we decided that this system cannot be in equilibrium. There was only one string, it was easy to tell. But in this case, today's case, there are 2 strings. And T1 need not be equal to T2. They are different strings, they can maintain different tensions. So can this system be in equilibrium? Is that possible?
So could you repeat?
I'm just asking, is it possible that tensions will be 20 and 40 and the system remains in equilibrium? Or should there be some relation between tensions which we need to check?
Sir, there is no connection between both the strings. Like there's no proper relation because it doesn't seem connected to the other string, both of the strings.
Observe
So
carefully. Is there no object or no point where these 2 strings are connected at the same time? Okay, let's solve another question before we come to this. Another simple case we will take. Fine. Observe carefully, all of you. Consider this situation. Assume there's a string passing around this pulley. This is a rigid support, and to that pulley a block is connected with a different string. So there are two strings in this case. Fine. Assume the block's mass is some, let's say 5 kg. Can this system be in equilibrium or not? If the strings are strong enough, can this system be in equilibrium or not?
Yes, sir.
It can. It is possible to support a block like this. One of you tell me what forces act on the block?
So 50 Newton downward.
50 Newton downward, that is its weight. And,
So and a common tension upwards, sir, on the string.
what do you mean common tension?
So that's
Okay, the usual one you are saying. Okay. So tension acts this way. There are two strings. In this string, I'll call the tension as T1. It should also be 50 Newton. We know this system will be in equilibrium, so the tension there has to be 50. Okay. Can any of you think of a way to estimate tension in the second string, to calculate tension in the second string? I'll give you a hint. Strings and pulley are ideal. What do we mean by an ideal string? What are its properties?
Say non-extensive.
Inextensible and massless. Okay. What are the properties of an ideal pulley? Ideal pulleys are also massless and they are very smooth. The string can easily slide over them. Usually you may have observed, no, people drawing water from a well, at least in videos you must have seen. When you pull the rope, the pulley rotates along with the rope. The situation will be somewhat like this. Suppose this is the pulley and a rope is passing over it. While drawing water from a well, person will be holding the rope on this side and pulling on it this way. When they hold the rope and pull on it, you see that the pulley also rotates, because the rope, as it moves, it kind of drags the pulley along with it. Because of friction between the rope and the pulley, as the rope tries to move this way, it will make the pulley also rotate like this. But an ideal pulley is frictionless. So in that case, what will happen? Rope will slide, but the pulley will not rotate because of the rope. Pulley stays like that. Even if it is free to rotate, it won't rotate. Why? Because even as the string slides over it, there's no friction between them. So pulley is perfectly smooth, it won't rotate. Okay, so that is what we mean by an ideal pulley. Anyway, the question here was, can we find out tension in the other string? Is the other string doing anything? Is it necessary, or can we just cut it off and the block will still be there? What is the other string doing?
It is supporting the 5 kg block.
It's not supporting the 5 kg. It is not connected to 5 kg, no? How can you say it is supporting 5 kg? That second string, that small string is supporting 5 kg. What is the long string doing? It is supporting the pulley. Okay, because see, a string is connected to 5 kg block. That short string is connected to 5 kg. I'm telling this to all of you. Gravity will be pulling the 5 kg downwards. The short string is opposing that. Okay, so on 5 kg, the short string exerts 50 Newton tension this way. The same short string on the pulley will be exerting 50 Newton tension in the downward direction. Do you agree with this or not? Will the pulley feel pulled downward by the string or not? Definitely it will. Okay. So the pulley experiences a downward force of 50 Newton this way, tension. Okay, in that short string, both sides the tension will be same. On the lower end, if it is 50 Newton, upper side also it will be 50 Newton itself. Okay, now you observe this pulley separately. That pulley is not falling down. No, even though the short string is pulling it down, the pulley is not falling down. What is preventing the pulley from falling down? Can one of you tell me?
The first string, sir.
The longer string, correct. Pulley doesn't have its own weight, but there is a tension of 50 Newton acting downwards. Because the pulley is massless, it doesn't have its own weight. Okay, or we are ignoring its weight, you can say. The other string is preventing the pulley from going down. Okay, now the other string has two contact points with the pulley. So there will be a tension acting here. There will also be a tension acting here. It's like that. How do we say tension acts on both sides? Now, like from everyday experience, if you cut off this side of the string, will the system still be balanced or it will fall down?
Will fall off.
It will fall down. So there is tension that side, there is tension this side also. Okay. So let's call that tension as T2. T2 acts on both sides. I mean, there are two T2s acting on that pulley. It's one string itself, but the string supports the pulley on two sides. So the 50 Newton, which is pulling it down, is balanced by 2T2 acting upwards. So we can say that 2T2 is equal to 50 because the pulley is massless. No, we discussed this point. Net force we know is mass into acceleration. If mass tends to 0, the net force on the object also tends to 0. Net force on a massless object is 0. Therefore, 2T2 should be balancing 50 Newton. There is no chance that they are unbalanced. The pulley is a massless object. The forces on it have to be balanced. So T2 becomes 25 Newtons only. That is the tension in the longer string.
Sir, so the it gets divided every time, right? Like into two.
If
Like
there are,
divided by.
yeah, if it is arranged like this, then yes. Okay, the lower string was connected to the pulley at only one point, but the longer string, the upper one, it's like going around the pulley, so it exerts tension on both sides. So whatever tension is there in that string, it will act twice on that pulley. Okay, hope this is clear to all of you. In general, if there's a pulley here and one tension acts this way, let's say T, and two tensions act here, then definitely they will be T by 2 and T by 2, provided the pulley is massless. Okay, net force on a massless object has to be 0. If you call these tensions as T and T, if you take this as T and this as T, then how much will this be?
2T.
2T. Okay. So you can distribute tensions that way in strings connected to the pulley. Now let us go back to the question that we were trying to solve. We were checking if this system can be in equilibrium. Let's see, for the system to be in equilibrium, the pulley also has to be in equilibrium. It should not accelerate. Okay, because if this pulley moves, then this block moves. Okay, or at least the other block, one of them will have to accelerate if the pulley accelerates, or maybe both also. But we don't want any acceleration. We want to check if it is possible that there is no acceleration in this system. Okay. Now for 2 kg to be in equilibrium, we found out that tension T1 has to be 20 Newtons. For 4 kg to be in equilibrium, we found tension T2 has to be 40 Newtons. Is there a way to connect T1 and T2? Now you all tell me. Is there any object on which both of them act so that we can relate them by writing Newton's law for that object?
So the pulley, the extra, the bound pulley.
That second pulley that is there, both tensions will act on that. Okay. So, okay, let me use a different color for T2. So on that second pulley, T2 will be acting here. It will also be acting here. And T1 will be acting on it in the downward direction like this. Okay, that short string, it will be pulling the 2 kg up, it will be pulling the pulley down.
So
Okay.
can you explain it again? How does that work? Like how is the T2 from here coming in these both strings?
It's the same string, no? This
Oh,
entire
okay.
thing
Yeah,
is
yeah,
one string.
yeah,
Ah,
yeah, yeah.
yeah. So there is T2, T2, 2 T2 acting upward on the pulley. That must be equal to T1. Right. So because the pulley is massless, 2 T2 has to be equal to T1. Let's see. T2 is 40 newtons, so 2 into 40 is 80, should be equal to T1 is only 20 newtons. Is this correct?
No, sir.
Clearly not. So 2 T2 cannot be equal to T1. That means this system cannot be in equilibrium. Okay, that is how you confirm that this system cannot be in equilibrium. Okay. So listen,
So
all
if
of
we
you. Yeah, tell me.
so if we change the masses for the 2 and 4, that
We'll
time
check.
it will be
Yeah, that is the next question. Okay. So what you were given a system, and I just asked you to check if the system can be in equilibrium. So what did we do? First, we wrote equilibrium equations for the blocks. From that, we found T1 should be 20, T2 should be 40. Then we are trying to write equilibrium equation for the pulley, but it's not. But we are getting an invalid equation. Okay, that means this system cannot be in equilibrium. Now, do the same check on this system, all of you. This time we'll interchange the blocks. So 4 kg connected here and 2 kg connected the other side. Can this system be in equilibrium is the question. Check it for yourself and type your answers in chat, all of you. Don't give out the answer. Let me extend this string just for clarity. Rishi, your answer is correct only. Yusuf, your answer is also correct. Okay, Aishwarya, what do you think? Can this system be in equilibrium?
Yes, sir.
Okay. How much is T1?
40 Newton.
40 Newton. T2?
20.
20. And will that pulley, that lower pulley also be in equilibrium with these tensions?
Yes, sir.
Okay. 20 acting this way and 40 acting this way. Net force on the pulley does become 0. So this system can be in equilibrium. What about the other pulley? We never talked about the other pulley. The other pulley, we don't have to consider it because it is connected to a rigid support. that support can give any amount of like that support can exert any amount of force. We assume it is strong enough. The ceiling is strong enough. So that pulley is not going to fall down or anything. This second one, let's call the pulleys also as P1 and P2. P2 is movable. P1 is a fixed pulley. Okay. It's fixed to the ceiling, but P2 is a movable pulley. It can go up and down. But that will also be in equilibrium. The entire system will be in equilibrium. But see, what is interesting here is a 2 kg mass is able to support a 4 kg mass. Okay. So you can prevent a 4 kg from falling down by using a 2 kg. That is why this is called a machine. Okay, it's not just a random system. It's something which can help you. Okay, in fact, cranes make use of this. Okay, cranes usually they are used to lift very heavy objects, right? But the rope that is connected to the like whatever the engine or motor that is there in the crane, it won't have to bear that much tension. It won't have to exert that much force to lift a heavy object. Okay, cranes make use of this multiple connections between strings, and this system is said to have a mechanical advantage. Okay, those things you learn in engineering. Okay, the ones aiming for NEET, you won't learn this anywhere. But the system is said to have a mechanical advantage. A smaller force is able to balance a bigger force. Okay. Anyway, let's go back to that question now. The original question, 4 kg on this side, 2 kg on that side. We found that this system cannot be in equilibrium. Okay. If it cannot be in equilibrium, okay, just a moment, I'll copy this. Right. We know this system cannot be in equilibrium. So calculate accelerations of the blocks. Okay, we have decided this will not be in equilibrium. So one of you tell me, which way do you think the 4 kg will move? Upward or downward if the system is released from rest?
Downward, sir.
Downward. Okay. See, I got answer from only one of you, means the others are yet to decide which way it is going to go. And it's quite possible, depending on how the system is designed, the heavier object may move up also. Okay. Now, in this case, it may be true that it goes downwards, but some of you are yet to decide, right? Even if you don't know, even if you're not able to visualize how it is going to go, which way it is going to go, assume some direction. The answer will tell you the correct direction automatically. What do I mean by that? Now, someone said, Vanilla said 4 kg is going to go down. Okay. Assume that to be true. Let it go down with an acceleration a1. And Vanilla, what do you think will happen to the 2 kg?
Will move up, sir.
It will move up. Okay. Let's say it moves up with an acceleration a2. What I'm saying is, suppose you don't know which way they are going, or you're not able to visualize which way they are going to move, then you choose whichever direction you want. You can assume 4 kg to be going up, 2 kg to be going down also, nothing wrong. Solve the equations properly. Finally, if you get a1 positive, that means the direction you have assumed is correct. In case you solve all the equations and you find a1 to be negative, that means it actually moves in the opposite direction. It actually accelerates in the opposite direction. Okay, so you can assume any direction, write equations according to that. The answer will tell you whether your assumption is correct or not. Okay, let's consider this direction itself and try to write the equations in this case. Now, I want you all to imagine how this system moves. That is very important. So we'll do that. If 4 kg goes down, we know that 2 kg has to go up. Like, Vanilla, why did you say 2 kg goes up? If 4 kg goes down, why should 2 kg go up?
Sir, I thought 4 kg will go down means 2 kg will go up.
Why? On what basis? Why can't both of them go down? అంటే ఏదో లాజిక్ యూస్ చేసి ఉంటావు కదా ఇండైరెక్ట్గా, తెలుసో తెలియకో.
అంటే ముందు ప్రాబ్లమ్స్ లో అట్లే అయింది కదా సార్, అందుకని ఈసారి అట్లా వచ్చింది.
ముందు ప్రాబ్లమ్స్లో కూడా అట్లా ఎందుకు అయింది? ఇఫ్ వన్ సైడ్ గోస్ డౌన్, వై షుడ్ ద అదర్ సైడ్ కమ్ అప్? ఎనీవన్?
So because the other was not fixed.
Because
The other one's not fixed, it just move up. There's
it
just
could have,
balancing on the
what is getting balanced? Okay, it is
so the
you have you
P2,
use the correct word, but what should get balanced?
so the P2 pulley 2 is balanced on the string.
String. Okay, see, it is all because the strings are inextensible. Okay, the length of the string cannot increase and the string cannot get shortened also. We know these strings are going to remain tight. Okay, they will remain straight. So the length of the string has to remain constant. Based on that, you can tell what will happen. Now let's assume 4 kg goes down, as one of you said. Okay, so if 4 kg goes down, let's say the string extends a little bit. Extends means goes down, it doesn't stretch. Okay, it's an inextensible string. Okay, maybe I should not use the word extends. The length of the string on this side increases. Okay, so assume 4 kg goes down a little bit like this. We know 2 kg should go up. Originally 4 kg was at this level. Okay, it went down a little bit. So if the length of the string has to increase on one side, then somewhere it has to decrease. And where is the only other possibility? At this point, it is rigidly connected to the ceiling. We can't get extra string from there. So the only thing that can happen is for the string to go down on one side, this pulley, the second pulley that is there, it will have to rise up. Now what will happen if that second pulley rises up?
So the 2 kg's string length will decrease.
The 2 kg string was originally like this. If that pulley rises up, just a moment, assume it rises to somewhere here. Then there will be a shortening, like all this length that is there. Or okay, just a moment. All this will not be seen anymore. Okay, the 2 kg will rise up. Situation will be like this. So this imagination is important. So we'll spend some time on this, not an issue. So are you all able to visualize this or not? If the string length increases on one side, then there, that side, on the right side, it will have to decrease. Is this clear to all of you? And by whatever amount the length increases here, by the same amount, it should decrease on the other side. So the red one and the green one, their lengths have to be the same. Okay. In fact, the green one should not be visualized like this. You should visualize it this way, this much and this much, because that U-shaped part was already there. Like this is what I'm talking about. This U shape is there in both cases. It's common. Okay, that is not changing. On the right side and left side of that hanging pulley, some string is getting shortened. Okay, some length of the string is getting shortened. Is this clear to all of you? Now, one red is balanced or is equal to two greens on that side. Okay, why are the greens equal? Like this pulley, you imagine it going up. Maybe it goes to some position here. Then basically what is happening is this part of the string and this length of the string and this length of the string, these will be free. Okay, and they are both going down on the other side. That same length is going down on the other side. Is this clear to all of you?
Yes, sir.
Okay. So if the 4 kg block goes down by a distance, let's say x, how much distance will the 2 kg block move up? Don't give out the answers, type your answer in chat. If the 4 kg goes down by a distance x, let's call this as y. How are x and y related? That is my question. Try to answer this, all of you. Type it in chat. This is x and this is y. Yusuf, Rishi, your answers are correct. Aishwarya, your answer is also correct. The green ones are the lengths by which the string gets shortened on that side. The red one is the length by which string gets elongated on this side, and they have to be balanced. So 2 greens have to balance the red one. Okay. So we can say that x is 2 times of y. Some of you wrote y is equal to x by 2. That is also correct. Okay. X is 2 times of y means the displacement of 4 kg block is twice the displacement of 2 kg block. Okay. Like if 2 kg rises up by 1 centimeter, suppose the 2 kg goes up by 1 centimeter here. Then string of length 1 centimeter, 1 centimeter, 2 centimeter string will become free, green and green. All that will go down on the other side. This will go down by 2 centimeters. Okay. So that is the relation between their displacements. Then same will be the relation between their velocities and accelerations as well. So what can we say? We can say that acceleration of 4 kg, x is on the 4 kg side, no? So acceleration of 4 kg will be twice the acceleration of 2 kg. And this is the constraint relation this time. Okay. So it's not necessary that connected objects will always have the same acceleration. It depends on how they are connected. So in this case, if you visualize, you will see that 4 kg moves twice as much as the 2 kg moves. So it's their displacements are related that way. Velocities, accelerations also will be related the same way. Is this clear to all of you how we wrote the constraint relation? Just imagination. One block going down, the other block going up. We visualize what happens to the string. One side we know we need extra string. The other side we know string length is getting shortened. We are relating them. The extent by which the string gets shortened should be equal to the extent by which it gets elongated on the other side. Okay, so we wrote an equation based on that. Okay, now let's get back to this question. The question was to calculate their accelerations. How do we calculate accelerations? Vanilla, don't say velocity by time, or we are using velocity and time. How can we calculate their accelerations? Like what equation?
We have
Force
to
by mass, sir.
We have to write Newton's second law, net force divided by mass, right? So Aishwarya, tell me, see, let me just remind you what we discussed yesterday. We are going to use the equation F net equal to ma. And I told you, these are vector quantities, net force and acceleration. They're both vectors. So if you are taking acceleration upward, you have to take net force in the upward direction. That is upward force minus downward force. If you are taking acceleration in the downward direction, then you have to take net force in the downward direction. Okay, accordingly, you'll have to write equations. Okay, now we have assigned directions of accelerations to them. Based on that, we will write. Aishwarya, tell me how will you write Newton's second law equation for the 2 kg block?
So T1 minus 20 Newton will be 2 times of A1.
2 times of A2, correct. Because we assumed A2 to be in the upward direction, we will write upward force minus downward force is equal to its mass multiplied with its acceleration. That will be the first equation for us. Okay. Yusuf, tell me Newton's second law equation for the 3 kg block. Sorry, 4 kg block.
So is it T2 minus 40?
Why did you consider T2 first? Why did you consider the upward force first?
So no, sir, I'm not actually thorough with this part of the chapter.
See, you're trying to apply F net equal to ma, which is a vector equation, right? And in whichever direction you are considering the acceleration, in the same direction you should consider the net force. Which way are we assuming 4 kg to be accelerating?
So downwards.
Downwards. Okay, the arrows drawn there. Okay, so how should you write the net force on it? Should you write downward force minus upward or upward minus downward?
So 40 minus T2.
You should write 40 minus T2 is equal to its mass multiplied with its acceleration. That becomes the second equation. And the third equation we already derived. It's the constraint relation. And as I said, to get the constraint relation, you don't need to apply Newton's laws. You just need to visualize how the system moves. Okay. Acceleration of 4 kg is 2 times of acceleration of 2 kg. That means A1, okay, the constraint relation tells you that acceleration of 4 kg A1 is 2 times of acceleration of 2 kg A2. This is the third equation for us. And how many unknowns are there? T1 is unknown. T2 is unknown. A1 is unknown. A2 is unknown. 4 unknowns are there. We need one more equation also. Can one of you tell me what other equation can be written?
T2 equal to 2 T1.
Correct. Okay. The pulley is massless and net force on the massless object should be 0. So you can write T2 is equal to not T2 equal to 2T1. It's actually T1 is equal to 2 times of T2 because T2, T2, they are both balanced by T1 on the lower side. So T1 is 2 times of T2. Or listen, while solving such problems, consider tension in one of the strings as T. Okay, let's say in the longer string, we take tension as T. If that tension is T, then this has to be 2T. Okay, in the shorter string, it will have to be 2T. Why? Because the pulley should be in equilibrium. Net force on the pulley should be 0. T and T acting upwards, 2T should be acting downwards. Now we'll change the equation slightly. On the 2 kg block, the tension now is 2T. So instead of T1, I'll write 2T. On the 4 kg block, instead of T2, let's take T. Now you will see that there are only 3 unknowns, T, A1 and A2. And we have 3 equations between them. So we have indirectly made use of the fourth equation already. Okay, solve these equations, all of you. 2T minus 20 is equal to 2 times of A2. Just a moment. Let's call, or okay, fine. Let's call A2 as A. Means acceleration of the 2 kg block. Let's call it as A. Then A1 will become 2 times of A. So A2, I will write it as A itself. These are things which will make you solve the equations faster. If A2 is taken as A, then the second equation will become 40 minus T is equal to 4 times of A1. What is A1? 2A. So this becomes 8A. Now you will see that you have only 2 equations and 2 unknowns. Okay, very easy to solve. Do it quickly, all of you. Calculate T and A. How much are you getting them as? Just take T from the first equation and put it in the second equation. Pawan, how much is T from the first equation?
So 40 minus 18.
Okay, second
Yes,
equation is going. Okay, let it be. You can do that also. From this, you send T that side and 8A this side. You get T is equal to 40 minus 8A. Okay. Now you have to put this in the other equation here. So 2 times of 40 minus 8A minus 20 is equal to 2A. That means 80 minus 16A minus 20 is equal to 2A. So send the 16A that side. 80 minus 20 becomes 60 is equal to 16 plus 2, 18A. That means A is equal to 60 by 18, that is 30 by 9. That also can be simplified, no? 10 by 3 meters per second square. Now what was A? We called A2 as A. What is A2? 2 kgs acceleration. And see, we got a positive answer for A. Means the direction we assumed for 2 kg is correct. This is 10 by 3 meters per second square. And we know A1 is 2 times of A2. So 4 kg's acceleration will be double of this, 20 by 3 meters per second square. Okay, is this clear to all of you? Okay, this solving the equation and all, some of you seem to be a little slow. Try it later, okay? I'll send you the notes. Video will also be uploaded. You can try it later. Let's try another question like this. Just a moment. In the meantime, you can go through the last question if you want. Okay. Calculate accelerations of the blocks. Surface is smooth. Pulleys and strings are ideal. I need to give you their masses. Let's say this block's mass is 2 kg. This block's mass is 3 kg. Solve it quickly, all of you. In this case, how the system moves is obvious. 2 kg will go down, 3 kg will come to the right. So just call their accelerations A1, A2, write the equations carefully. And to begin with, consider tension in one string as T. For example, let's say we take the tension in the longer string as T. Then one of you tell me how much will be the tension in the shorter string?
V by 2 T by.
Why will it become T by 2? And why did you say T by 2 twice? We took tension in the longer string as T. Based on that, you tell what is tension in the shorter string. Anyone?
Oh, yeah, sir. Same string, so it'll be same only.
That part is okay. This lower part, short string is there, no? How much will this be? If tension in the upper string is T, how much is this? Anyone? Pulley is ideal, massless. So net force on the pulley has to be 0. Based on that, you tell me how much this should be.
2T, sir.
2T. Yes. The same 2T will be acting on the 2 kg block in the upward direction. On pulley, it will be acting downward. On block, it will be acting upward. Okay. Write equations and calculate the acceleration, all of you. I'll give you 3 minutes to solve. Okay. Can one of you tell me the constraint relation in this case? How are accelerations of 2 kg and 3 kg related? Okay. Let us visualize first, and then I'll teach you another method also to derive the constraint relation. The other method is actually easier, but visualization is also important. Some of you, like I find that visualization thing easier to do. Anyway, it depends. So listen, let us visualize how this system is going to move. We know 2 kg will go down. For 2 kg to go down, the pulley that is connected to it also has to go down. Imagine it going down by, let's say, some distance. Assume x. Now tell me, for 2 kg to go down by a distance x, how much should the pulley connected to it move? This pulley that I have highlighted, how much should it move?
X/2, sir.
Why? అండ్ స్ట్రైట్గా ఒకటే దారం కనెక్ట్ అయి ఉంది కదా రెండింటికి. ఇది ఎంత మూవ్ అయితే అది కూడా అంతే కదా మూవ్ కావాలా. there's one string directly connecting 2 kg to that pulley. Okay, let me mark the ends of that string. You look at these 2 green dots. If this green dot goes down by x, then the other one also should go down by x only, because there is one straight length. Do you all agree with this or not?
Yes, sir.
So if the 2 kg block goes down by a distance x, then this pulley also will have to go down by the same distance x. Let me draw the same arrow for x. Let's say 2 kg goes from here to here. Okay, maybe not so long. Just a moment. Yeah. Then the pulley also will have to move by the same distance. So I'm copy pasting that arrow. This is what is going to happen. You can imagine this block also somewhere down. Like this. Those are their new positions. This is x. This will also be x. Fine. For that pulley to go down by a distance x, how much string will be needed? How much extra string will be needed? Or what length of extra string will be needed on that side? See, that U-shaped part will still be as it is. Okay. But we need some extra length of string here and also some extra string here. Let me just pull that arrow aside. Okay. Are you able to visualize how the string has to, how much extra string we need on both sides here? We need some here and some here. Is that correct or not? Where will that extra string come from? That extra length, where will it come from?
3 kg.
From the other side 3 kg, because this end is fixed. That cannot move. The 3 kg is movable, no? So string will come from that side. So basically what happens, the 3 kg moves forward. Just a moment. Now 2 kg block, we assumed it goes down by a distance x. If 2 kg goes down by a distance x, how much extra string is needed on this side totally? For 2 kg to go down by a distance x, how much extra string is needed?
2x.
2x. Okay, correct. We need x on this side of the pulley. We need x on this side of the pulley as well. So for a displacement x on this side, string needed is 2x. Where will all that come from? It will have to come from the other side. So the 3 kg block will have to move forward by a distance of 2x. So 3 kg maybe goes somewhere here, or okay. So 1x and another x. You will see the 3 kg coming here. The string will get shortened by 2x on that side, because it has to increase x and x on this side, x plus x. Is this clear to all of you? Any doubt in this? Okay. So if the 2 kg has to go down by a distance x, the 3 kg will have to move to the right by a distance 2x. Now let's apply the same relation to their accelerations. If 2 kg has to have an acceleration a, tell me how much acceleration will 3 kg have then? We know the relation between their displacements. What will the relation between their accelerations be?
2a.
2a. It will have to be 2a. Because when this was x, when this goes down by x, this had to go to the side by 2x. So similarly, if 2 kg accelerates with an acceleration a, 3 kg will have to accelerate with an acceleration 2a. Only then the length of the string can remain constant. Okay, that is the idea we are using. Is this clear to all of you? Did you all understand how it was x and 2x? If you have any doubt, you can ask, feel free.
Sir, can we do this by the one method which we did the previous question, and like making two equations and then we get so many variables? But will that become more cumbersome?
See, constraint relation is an independent equation. In the previous problem also, we derived the constraint relation. No, we got x is equal to 2 times of y. Then we use
Yes,
the
sir.
other equations. We use this equation in combination with the other. Okay, you are saying instead of taking a and 2a, let's just call them as a1 and a2.
Yes, sir.
But finally, you will have to use the relation that a2 is 2 times of a1.
Okay, sir. Okay. So this
Okay.
just makes it easier.
This makes it easier. Call it a and 2a. So you have already used that equation, a2 is equal to 2 times of a1. So now if you write net force is mass into acceleration for the 3 kg block and for the 2 kg block, you will only get equations in terms of T and A. 2 blocks, 2 equations, and there are 2 unknowns. You can solve them. Okay. Solve it all of you. Calculate acceleration of the blocks. Vanilla, tell me what equation you'll write, or how you'll write Newton's second law equation for the 2 kg block.
Twenty minus 2t equal to 2a, sir.
Correct. We assumed its acceleration is downward. So downward force 20 Newton, that is its weight, minus upward force 2t should be mass into acceleration 2a. Next, Rishi, tell me what equation you'll write for the 3 kg block.
So 3t minus 30 is equal to 2a.
Why 3t minus 30 and all? Which way is it accelerating?
Oh, right side. So only t. So
That's all.
t minus 30 is equal to 2a.
Why will you subtract 30? Is there 30 Newton acting this way on 3 kg?
No, it's going along the
30 Newton is its weight. Weight acts this way, which is balanced by normal force. They don't matter. It's moving horizontally. What is the what are the horizontal forces acting on 3 kg?
only the tension and
Then you will write
the acceleration. But it's like,
acceleration is not a force. Okay. Due to tension, it gets that acceleration. So how you'll write the equation? Anyone? The only force dragging 3 kg is tension. So you'll write tension is equal to mass multiplied with its acceleration is 2a. That's all. So T becomes 6a. Put that in the first equation. If you put it in the first equation, you get 20 minus tension is 6a is equal to 2a. That means 20 is equal to 8a. So a becomes 20 by 8. That is 5 by 2. 2.5 meters per second square. And what is a? A is 2 kg's acceleration. 2 kg's acceleration will be 2.5 meters per second square. That makes 3 kg's acceleration equal to 5 meters per second square. That is how they are going to accelerate. Okay, just recollect what all we did in this question. Ask if you have any doubts. After this, I'll tell you the other way to derive constraint relation.
Sir, I have a doubt.
What is it?
So since T is equal to 6a, if we substitute it in the 2 kg equation, won't it become 12a?
Okay, yeah, correct. I made a calculation mistake. T is 6a. There we have 2t. So it should be 2 into 6a, that is 12a. Correct. So 20 becomes 12 plus 2, 14a. A becomes 20 by 14, that is 10 by 7 meters per second square. Yeah. Any other doubts? Fine. So let us look at another way to derive the constraint equation. Do any of you know how work done by a force is calculated? Work done by a force, how is it calculated? Okay, listen. Suppose there's an object. There could be any number of forces acting on it. Let's consider one of the forces acting on it. Assume it acts like this. Let's call the force as F. And as a result of all the forces acting on it, assume the object undergoes some displacement. Let's say it undergoes a displacement this way. Let's call the displacement as S. Magnitude of displacement, I'm taking it. The displacement is actually a vector quantity. We are supposed to indicate it with a bar. But since I have shown the direction with the arrow, I'm just writing its magnitude as S. Let the angle between these two be theta. Okay. Then we say that this force has done a work equal to Fs cos theta. So work done by any force depends on the force, depends on the displacement of the point on which the force is acting, and it also depends on the angle between the force and displacement. Okay, it is defined like that. You'll understand why. Okay, next chapter is work, energy, and power. In that we will discuss work in detail. Okay, but to get constraint relation in an easier way, you'll need to know this formula for work. That's why I'm explaining. So see, this displacement need not be the result of only this force. Displacement of an object depends on all the forces acting on it. On this block, there are other forces also. Weight is acting, normal force is acting. Under the influence of all forces, let's say it undergoes some displacement S. Okay. If you want to find out the work done by this force F, this is how you do it, Fs cos theta. You can find out work done by other forces also this way. Okay, if you want to find out work done by normal force, then you will do normal force multiplied with displacement multiplied with cos of the angle between them. Similarly, you can find out work done by gravity also. You can find out work done by any force if you know the force, displacement, and angle between them. Okay, so this is the basic formula for work. Now tell me, suppose the force acts in the same direction as the displacement. Somehow this is happening. Then how much will the work done by that force now be? Just use the formula as it is, Fs cos theta. If force and displacement are in the same direction, how much will theta become and what will the work done become?
Force into displacement, sir.
That's all. It will directly be Fs cos 0. Cos 0 is 1. So it will simply be F multiplied with S. Force multiplied with the magnitude of force multiplied with magnitude of displacement. So if force and displacement are in the same direction, you can calculate work this way. Suppose they are exactly opposite to each other. Suppose force is acting to the left, but displacement is to the right. As I said, like some of you may be getting this doubt. If force is to the left, how is the block going to the right? As I said, that displacement is a result of all forces acting on it. There might have been other forces acting. Who knows? Okay. But we want work done by this particular force. So in this case, one of you tell me how much will the work done be?
So negative work,
How much?
negative Fs.
Okay. It will be Fs cos. This time the angle between the force and displacement, since they are opposite to each other, the angle is 180 degrees and cos 180 degrees is minus 1. So it becomes minus Fs. So it's possible for a force to do negative work also. Okay. So if force and displacement are in same direction, it is Fs, opposite direction minus Fs. In general, it is Fs cos theta. Right. So just remember this much, this formula for work. Now the idea, how do we use that to get the constraint relations? The idea is that internal forces, now see, these are all solid objects that we are considering. Okay, the 3 kg block, the 2 kg block, the string is inextensible. Fine. So there's no compression or elongation allowed anywhere. In such cases, if there's no object or anything getting compressed or elongated, total work done by internal forces within a system will be 0. It will be 0. Okay. Now, what are internal forces? Consider this question itself. Our aim is to derive the constraint relation. Basically, what we want is a relation between their displacements. Okay. So let's assume 2 kg undergoes a displacement x downwards and 3 kg undergoes a displacement y to the right. We need a relation between x and y. That is the constraint relation we are looking for. Now we know what forces act on them. Fine. Now to this system, gravity is an external force. It is exerted by the earth. Normal force from the table is an external force. It's exerted by the table. The blocks are connected by the string, right? The force exerted or forces exerted by the strings, string or strings, are the internal forces to this system. Fine. So for now, you just remember it this way. If there is a system connected by strings, the tension in the string or strings becomes the internal force. And the idea to derive the constraint relation is that total work done by internal forces on the system is 0. We will write this equation, okay? We'll write expression for work done by tension and equate it to 0. That will give us a relation between the displacements. How? Work done depends on displacement, no? So in that equation for work done equal to 0, you will have displacements involved. Okay, let's see. Listen, all of you. What are the parts of the system undergoing displacement in this case? Which parts of the system undergo displacement as it moves? We are trying to write an equation for work done, okay, on the entire system. So we have to see where there is displacement happening, because only when there is displacement, there is work. Fine. So one of you tell me which part or parts of this system are going to move.
3 kg block and 2 kg blocks.
And then, is there nothing else which moves?
Sir, even the string.
String, okay, string will anyway move. Fine. What
Pulley
else?
also will move.
Pulley. One of those pulleys also will move. Okay. Which of them have mass? Because the net force on a massless object is 0. So on the massless object, for example, this pulley, the forces will be balanced. The work done on pulley will automatically come out to be 0. You don't have to include it in the equation. Okay. So consider only the parts which have mass now. 3 kg, 2 kg. Okay, let's include pulley also, since this is the first time we are writing the equation. Let's name the moving parts as A, B, and C. Block A, block B, and pulley is C. Okay, these are the moving parts. String is there, but you don't have to write work done on the string. Tension acts within the string, no? Due to tension, where is work being done is what we need to check. So work done on A plus work done by tension on B plus work done by tension on C. That gives us the total work done on the entire system. Okay, we have considered all the moving parts of the system, no? So you add the works done on all of them, that will give you the total work. You'll have to equate that to 0. Now look at the pulley first. On the pulley, there is T and T, 2T acting upwards. There is also 2T acting downwards. So what is the net tension on the pulley? It is 0. Therefore, work done by tension on the pulley will be 0. Because the net tension, its net force itself is 0, work done will be 0. Okay, next A and B. On A, the tension is T. And A undergoes a displacement Y. You see this tension, this displacement, you can tell the angle between them. One of you tell me, what is the work done by tension on A in terms of T and Y? Tension, the force is T, the displacement is Y, they are in the same direction. How much will the work done be?
YT, sir.
YT, correct. Force, see, when they are in the same direction, it is Fs. So force multiplied with displacement directly. So it becomes Y into T. Okay. That is the work done by tension on A. Plus work done by tension on B. On B, the force is 2T. The tension is 2T. That's the force whose work we need to find out. And the displacement is X in the downward direction. So one of like you all can observe their directions. Force is 2T. Displacement is X. What is the work done on 2 kg? Pawan?
Sir, minus 2tx.
Correct. It will become minus Fs because force and displacement are exactly opposite. So it becomes minus 2tx. That's all, equated to 0. T will get cancelled. And you get y minus 2x is 0. That means y is equal to 2x. Okay, using that visualization method also, we got the same relation between them. Y was equal to 2x. Okay, now we have written work done by tension on the entire system is 0 because tension is the internal force acting between the objects of this system. Okay, so work done by internal force on the entire system, you equate it to 0. That way also you can relate their displacements. And we made use of that here. Now I want you all to do this in the previous question that we solved. Here using visualization, we derived the constraint. Okay, we got A1 is 2 times of A2. Okay, later on your own, write like how do you start? You take displacement of one of them. We are assuming this is going up. So call this as X. The other one is coming down, call it as Y. Name the displacements as X, Y. If there are more than 2, Z, you use whatever words you want, whatever letters you want. S1, S2, S3 also you can write. Then write the tensions. Okay, you have to know the relation between the tensions. Here we know T1 is 2 times of T2. Okay, or I think it is better to use this diagram. Yeah, T and 2T, we have connected the tensions, we have related the tensions, and assume this goes up by a distance X, this comes down by a distance Y. You write work done by tension everywhere, equate it to 0, check if you are getting the same constraint relation or not. Okay. Fine, we'll stop it here for today. So today effectively what we did is we discussed cases where connected bodies don't have the same acceleration. Okay, and we learned how to derive constraint in such cases. One is by visualizing them moving. Okay, you just have to assume one of them moves by X, then how much extra string is needed, how much or by how much the string gets shortened, that you have to find out, and you have to balance it on the other side. That is one way. The other way that I just explained is by writing total work done by tension on the entire system equal to 0. Using that also you can relate their displacements, and from that you get the relation between their accelerations. After that you apply Newton's laws and solve the problem. Okay, so do that all of you, right? Work done by tension everywhere equal to 0 in that previous question, and check whether you get the same constraint or not. And I'll send you some practice questions based on that. It will become easy for you. Okay, thank you all. I'm closing the session. We'll continue on Wednesday.
Thank you, sir.